Hello and welcome to part 2 of step 29. So in this step we're going to learn about secants and then combine secants with tangents to talk about angle measurements. So the first thing we got to talk about is what is a secant. So a tangent line, remember, we had a tangent line, we had a circle, and this was a line that just barely touched the circle, but only touch the circle at one point, okay? The difference between a tangent line and a secant line is a secant line touches the circle at 2 points. So in this picture, both of these segments are secant lines, J and K, because they both hit the circle at 2 different points. So it's, imagine like a chord, whether the chord's a diameter or not, doesn't matter, but the chord just goes actually through the line. Okay, so we're going to talk about 3 different types of angles. So this first one, all of the angles are inside of the circle. Okay, so this is talking about inside of the circle. When we have these angles that are inside of the circle, we've created 2 straight lines, so we have vertical angles. And in order to find angle 1 or angle 2, what we would do is we find the average of the arcs. Okay, so remember that angle 1 and our angle across from it, those are vertical angles, so those would be the same. Same idea with angle 2 and its angle across from it, those two are the same. So what we're going to do is take the arcs that both of those angles create. So for the blue ones, we would take AD and BC. We would add them together and divide by 2. To find our orange angles, angle 1 and the angle across from that one, we would find the average of the arcs between AB and DC. So we would add the 2 red arcs together and divide by 2. So if we look at our first example, okay, remember that this angle, because we have 2 straight lines, these 2 angles are congruent to each other. So when we look across from those angles, we'll see this arc right here and this arc right there. Okay, those are the 2 arcs that we're going to take the average of. So in order to find angle X, if I actually wrote this out, I would use the measure of arc RS, I would add it to arc TU, and then I would divide by 2. So really we're just doing 84 plus 130 and then dividing by 2. Okay, when you go to put this in your calculator, make sure you do the addition first, or actually put it as a fraction. So 84 plus 130 is 214. Then 214 divided by 2x should be 107. That would be our final answer. Okay, let's just do one more. I want to look at a slightly different problem. So in B, we're looking at same sort of picture, right? We still have angles inside of the circle, but this time, if we look, the way that our arcs are labeled, this arc and this arc, let me make my highlighter smaller. This arc here, A to B, and this arc here, C to D, should actually find these 2 angles here. So let's just call this Y. Okay, that angle is not the angle that we want. But if we go ahead and just find that, we could say that, all right, we wanted Y is going to be the average of the 2 arcs. So Y is going to be equal to 143 plus 75 divided by 2. So 143 plus 75 is 218. Divide that by 2. Y would give us 109, if I'm not mistaken. Okay, so now I know that y is equal to 109, but I really want to find x, so I'm not finished, okay, but if I look at x and y are sitting next to each other. They're sharing the vertex E, and then they are sharing the arm EB. Okay, so I have this straight line here, and then they're forming that straight line. Two lines that form a straight line together are called a linear pair. Okay, a linear pair is also supplementary to each other. So I could say angle X plus angle Y should add up to 180. I already know angle Y is 109, so I'm going to plug that in. Subtract 109 from both sides, and my angle X is actually, 71. And that would be my final answer. Okay, so the second way we're going to talk about these angles, slightly different. This time, instead of two secants going through the circle and all of the angles being on the inside of the circle, these angles are going to be on the side of the circle. So we're going to have a tangent line and a secant line together. Okay, these ones, so these are going to be on the circle. Okay, the first ones were inside the circle. These are moving to on the circle. So the only other angle we've talked about so far is, the only other angles we've talked about before this were central angles and inscribed angles. These, just like inscribed angles, are on the side of the circle, and they're going to work just like an inscribed angle. Okay, just like inscribed angles. So when we had an inscribed angle, we either double it or we half it. Okay, so if angle, let's say this red arc here was 100, if we went back to this angle, angle 1 would be 50 because we're getting smaller as we're going towards that angle. So if this red piece of our circle is 100, but I have the whole circle in my picture, I could do 360 minus 100 would give us 260, and that would be the measure of my blue arc. And then when I'm going from my arc back to my angle on my circle, I'm going to divide that by 2. So 260 divided by 2 would be 130. Okay, so these ones on the circle work just like inscribed angles. We're either going to double it or we're going to half it. So let's do a couple examples of these. So we want angle PQR. So I'm going to highlight that so we make sure. So we're going from Q over to P and out to R. So this is the angle we want. All right, so we're going to look out to the arc that this angle has created, which is 148. Okay, so if we have the angle or the arc measurement, in order to get back to the angle, in order to get smaller, I'm going to take my arc measurement, which would be PR, and I'm going to divide it by 2. So really, my angle is just 148 divided by 2, which is 74. Okay, let's do one more just like this. So this time I'm looking for arc DE to F. So I'm going to start at D, I'm going to travel through E, and then out to F. So I'm looking at that big piece of the circle out to the left-hand side. Well, I don't know the angle back at D that would help us, but I do know if this angle here is 64, to get out to the arc, I can say, well, then the measure of arc FD should be 2 times that angle. So it should be 2 times 64. So really, FD is 128. So I have 128 outside. So my big picture, the big arc that I want, has everything, is every part of the circle except for that arc 128. So if I travel all the way around the circle, remember it's 360 degrees, and I know my one part is 28, so if I take that off, that means I have 232 left to give to my arc. So this big arc out here is 232, which is exactly what we wanted to find. So DEF is 232. All right, we got one more type of angle to talk about. And this is when the angle occurs outside of the circle. So this is outside of circle. So we talked about inside, we talked about on. This time it's outside. So how this one works is we're either going to have two secants, a secant and a tangent, or two tangents. So the big picture about this is no matter how if it's whatever combination it is, it's always you're having a bigger arc with a smaller arc and then some sort of angle. So the equation for this, you're going to see me write the angle is equal to the big arc. Notice in this picture, it's all the red ones, minus the small arc, which is all the blue ones, divided by 2. That's our equation. Okay, so if we look at our first example, we want to find angle L. So we're looking for our angle. Remember, our equation for these problems, the angle is equal to big minus small divided by 2. Okay, so we're looking for the angle, so I'm going to plug in angle L. We don't know our big arc yet. Our small arc is 102. We need to find that big arc. So if we look at this picture, the entire entire circle is within this picture. So if I go all the way around the circle, I will get to 360. So if I do 360 minus 102, that means I have 258 degrees to give to this red arc out here, which means my big arc is 258, my small arc was 102, and then I'm going to divide those by 2. So I'm going to write out, make sure you do the subtraction first. 258 minus 102 is 156. Then we're still going to divide that by 2. And our answer is 70. Sorry, I just got really confused. I was looking at the wrong page. 78. All right, I want to do one more just like this. Okay, so just a refresher, the equation again is the angle is equal to the big arc minus the small arc divided by 2. Okay, so this time I actually want one of the arcs, which I want CD. So in this picture, CD is the big arc. That's our unknown, and we know everything else. So the angle measurement is 56. The big arc is our unknown. Let's just, for the time being, we can plug in measure of CD. My small arc is 95. And then divided by 2. Okay, so we've done a couple examples like this with solving an equation like this when we talked about mid-segment. So we want to get the measure of CD by itself. We got this minus 95 and this divided by 2. So the first thing I want to do is multiply both sides by 2. Okay, so 56 times 2 is 112. When I multiply the right side by 2, the fraction just goes away. So I have the measure of CD is Wow, that was weird. The measure of arc CD minus 95. Can add 95 to both sides. 112 plus 95 is 207. So 207 equals the measure of arc CD. Okay, and that's it for this step. I'm going to show you one last thing. So at the very bottom of your notes, I put this chart in here. So this is kind of a nice little visual if you want to compare all of them. So when we have the angles on the circle, we are going to either double it or half. I don't know why I wrote of. Okay, these are the ones that are the same as inscribed angles. When we are inside the circle, on, inside, or outside. If we're inside the circle, we're finding the average of the arcs. And when we're on the outside of the circle, the angle is equal to the big arc minus the small arc divided by 2. Okay, but that's just a nice kind of recap of all three put together in the same spot.